Welcome back. So in this lesson we're going to look at scene transitions. So if we go to our house and we press triangle to go in, we can see that this is a separate scene from the outside world. We have this camera that tracks us. We don't have our full camera the way we had at the outside. And of course if we go back out again, we spawn right here outside the door. So in this lesson we're just going to focus on loading the new scene and creating the new scene, and the correct spawning will be in the episode after that, just to kind of simplify things, because this would be pretty long if we did both things. So yep, that's a jump to Unity. Okay, so the first thing we're going to do is we're going to add a house. So if we go to our polygon starter folder and then do prefabs, we should have some buildings here. Let's take a look. Door, we're going to need this. Don't need any of that. There we go, we use this. Drag and drop in the scene. And let's pull it over this way. And let's rotate it. -90. Okay, so this will be the house we're going to enter. And we're going to have to add a door as well. Let's just pull it forward a little bit more. Okay, and now if we go back to that door, bring that into the scene, bring it over, just line it up. Of course, this needs to be rotated -90 as well. Back, bit up, bit forward. I think that's fine. Yep. So this door is going to be the trigger that we use to actually transition between scenes. So instead of actually making this set as trigger and writing some code, we're actually just going to make this a different layer, and the player is then going to check for those different layers. So if you would layer, add layer, door, go back to your prefab, change the door layer. Also, let's just unpack this prefab while we're here. Unpack completely, same with the house. Unpack completely, let's change the name to house. And door. And we'll make the door a child of the house. Okay, so now we have the door on the door layer. We're going to need a script for this as well. So let's go to our scripts folder. And when I make projects, I like to make a tools folder. And essentially what it is a folder with really generic scripts that can be reused between projects. So I think this is one of those scripts where we could definitely import this in a different project that's a different genre of game, and it'll be handy to have. So tools, create C# script, door. Let's double click to open. And for now, all the door is going to contain is simply a string of the scene name that needs to load into. So scene name. And that's it for now. We can add more to this later, but this will do for now. Now, let's back to our game. Now let's actually create the scene that this is going to load into. So we go to our scenes folder, let's do create new scene. Where's scene here? Scene, and go house. Double click, save. So this will be the new scene it loads into. So let's actually go back to our older scene and let's make some prefabs first that we can bring in, so we're not starting from scratch. So we don't have a folder created already. Let's go create folder, prefabs. And we're going to need this house again. So open there, drag in the house. Let's just reset some of these positions too, so when we spawn in this house in a different scene, it doesn't automatically rotate to this setting. What else do we need? Things like a game manager. I think we're going to want to persist between scenes. Every scene should have a game manager. Or maybe not, but we do want this as a prefab, I think. So let's just create an empty object called game constants. Let's just drag this to the very top. And under that, we're going to add our game manager. And what else? Player might not be in every scene. Maybe we load in the level where it's a race or something, like a car race, and our player might not be loaded in then, or something different, a mini game or something like that. So let's not add the player to the game constants. Same for camera, it might not be in every scene. Main camera, that'll be in by default. NPC, okay, I think that's fine. Let's go back here, drag and drop this into the prefabs folder. Now let's actually just go into this open. So by default, yeah, these are going to be empty, that's fine. Now if we go back to our scenes, our house, save, go to our prefabs, drag and drop this house in. So this time we're actually going to be inside the house. So in this scene actually, because this is indoors, I don't want the outside skybox. I think I'm going to change this from skybox to solid color. And let me see, what's black look like? This is a scene view, so it'll always show the skybox, but yeah. Let's just add in our player. Oh, we didn't make a player prefab. Let's drag and drop the game constants in too. Let's add this to the top, and then let's go back to our other scene. Control S, save the scene, and then back to our scenes, sample scene, player prefab. We want that, and the prefabs folder. Let's make sure there's nothing here that's specific to this scene. Nope. And then, of course, we go back to house, save, and we drag and drop our player in. So our player's there. Let's just raise them a bit more off the ground, maybe 0.5, because of course we know from before that sometimes these feet kind of pop up then once the game starts playing. So I think we just leave them a little sunken into the ground. We'll see how it goes. For camera then, for this scene, we're actually going to use a third-person camera. As you can see in the game, a lot of the interior scenes use these fixed cameras that track the position of the player. So that's very simple. We're using Cinemachine, which is already installed. So if we go to Cinemachine, and I think it's 2D camera blend. Let's go virtual camera. And let's say that it is looking at the player. Now if we just drag this back, down, just put it in the corner of the room just. Now it's kind of dark in here, so let's just add some lighting. So create light, let's go point light. Let's reset this to 0, right in the middle of the room. And let's just increase the intensity a bit. 5 with the range. Yeah, still very dark. I think what we could do is if we have our lighting tab, if you know it does open, you can just go Windows and then rendering lighting, and that'll open the lighting tab. If we then go to the environment, our source lighting, instead of going to be from the skybox, we'll just say color, and let's change this color to white. And now we get this nice bright scene. So I think we can actually press play in this scene. Let's go to our game constants first, our game manager, and drag and drop our player. So of course this is not going to have a third-person camera in this scene. So let's just make sure we cover that in the code. Double click to open the game manager. So let's just say if third-person camera is not equal to null, then we can initialize the camera. And then let's do the same thing for our update. If the third-person camera is not equal to null, then update the camera. Let's remove these as well if we're not using them. Now back to the scene, let it recompile. Let's press play, see if this works. Yep, there we go, and you can see the camera tracks, and that didn't require any code from us. So our exit door will be here, because this is what the scene was on the other scene, the kind of overworld level, as you would call it, the open world. Perfect. So now if we go back to that scene, let's just Control S to save, back to the sample scene. So sample scene is the one we've been demoing in so far. And now we need to start working on the logic for detecting this door. So let's go to our player, double click, open up the player controller. Now we're going to create a new method called void check for door, and we're going to say collider. It's going to be an array of colliders. Say calls for short for colliders. It's going to be physics dot overlap sphere. Okay, so now this is going to need an origin. So let's just go up to our variables. Let's create a new header. Let's call it door check, small h. And first we're going to need a transform called our check origin. We're also going to need a radius. So serialized field float check radius. And we're also going to need the layer that the door is going to be on. So int door layer. Let's go back down. Our overlap sphere is going to start at our check origin, that position. Then it's going to be a check radius. And then it's going to be the door layer. So this is where layer is going to look out for. So door layer. But we're also going to have to, what's this called, bit shifting this. So go 1 and then 2 less than symbols. And that'll make the layer mask for this check. Now, if collider's length is greater than 0, so that means the door is detected. And then we'll go for each collider in colliders. We'll say, let's capture the door component. So door, not for, door equals call dot get component door. And then if this is not equal to null, we're going to load our next scene. So let's just add some pseudocode here for a second. So load scene, and then it will be door dot scene name. So now we need to actually create a scene loader. So what's going to be unique about this scene loader is it's going to persist between scenes. So we're not going to add this to the next scene, the house scene we're creating, because it'll actually carry over from the scene once we load. So let's go back to our game. Let's go to our scripts again, and let's just create it in this folder for now. C# script. Let's call this. So we're not going to call it scene manager because I think Unity already has a system for scene manager. So let's call it scene handler, just to avoid any conflicts. We could use namespaces, which would solve that. Unity already uses its own namespaces, so it might not actually cause any issues. But I think it's better to do it this way, it's cleaner. Double click to open. Delete all this, of course, as we always do. And we're actually going to make this a singleton as well. So let's go public static scene handler instance, and then in our awake method, if instance is equal to null, then instance equals this. But if it's not, then we're going to destroy this game object. Now let's create our function. It's going to be public void load scene, and of course we're going to take in the scene name And then we're going to call this scene manager. This is going to actually import some stuff now. Scene manager dot load scene name. Let's delete all this stuff. We don't need it. Now, as I said before too, what we're going to do for this is make sure it doesn't destroy once we load a new scene, because we're going to carry it over throughout the scenes. So just here we will add one line saying don't destroy on load this game object. Now if we go back to our player script, now if we actually implement this properly, we can say scene handler dot instance dot load scene, and there we're going to say door dot scene name. Let's go back to our game and let's add this. So create empty. Let's call this let's just call this scene handler for now. But I think we'll use this game object as just as a generic object that we attach all our scripts to that we don't want deleted, on load, or destroyed. So let's just add that. Scene handler, perfect. Okay, so now we have this method. Let's call it within our player update flow. So now when do we want to call this? Well, if a collider is detected on this layer and we want to make sure that an input was pressed on the controller, so let's just take in our input container. Input container, and let's say and input container dot a input dot pressed. Now if we go back up, of course we need to put our input container in here. Let's save that, and let's go back. Let's double check everything first. So we have our house, we have our door, doors in the door layer. Let's check what layer that is. It's layer 8. If we go back to our player, now we need to make these variables. So we know this is 8. We want the check to start. Let's actually just press F, go to our player, create empty, check origin. Let's just move this a little up until the center of the player, so just 1 on the Y. Add this, and let's make our radius, let's make it 2. Of course we made all these changes to the player, so if we go to the player, overrides, apply all. Gain constants, yeah, we made no changes. House, made no changes, so that's fine. Our door, we haven't attached the door script, so let's do that. Door, and then the scene name that it's going to load. If we go to our scenes folder, we call it house, so we call this house. And of course, for anything in Unity with scenes, we need to add it to the build. So I think it's file, build settings. We already have our sample scene in the build, so if we add the house, there we go. Okay, let's see if this works now first time. Let's press play. Let's go over to this door. And there we go. We load into this scene. And then if we go back, so it's this door again, let's press A or space in the keyboard, whatever the setup is. Okay, so if you know the reason why this one, it's kind of obvious. It's because we never set the name for the scene. So let's go back, go to our house scene, save this, house, door. So we actually need to go back again. We need to apply this to the prefab, apply, back to the house, door, and this is going to load the sample scene. So let's just try that again. Go back to sample scene, So if we actually let me just make this smaller, minimize. So if we look at this don't destroy unload and we expand that, we can see our scene handler here. So now if we go over to the house and we enter it, we can see that don't destroy unload, that's still there. And now we can go back over this door, let's hit space, and we're back here. So now the last thing I want to do in this lesson is to add the transition we see in the game of the circle getting smaller and bigger again. So it's going to be quite quick. So let's get our assets first. So art, let's create a new folder called textures. Now I've created these in Photoshop. I will add these to a link, a Google Drive link in the description. So if you want them, you can grab them, or you can make them yourself. It's very simple. Drag and drop these in, just a simple black background and a circle. So these are going to be sprites. So let's change it to 2D sprite. And then we apply, we can see the circle now. And this will also be a sprite. So 2D sprite / UI, apply. I think we can actually make these sizes smaller because as you can see here, this was created as 1024 by 1024, which is probably still too big for this game. We can probably crush this down smaller in size to save some memory, but we'll look about that later. Same with this, it's 1920 by 1080. It could probably be smaller, it's just a black screen. Yeah, let's just leave it for now. So let's create some UI. So UI, let's create a canvas first, of course. Let's just call it canvas. And so the first thing on our canvas is going to be the circle. So create UI image called circle. And let's just add this. You see it here now on the screen. And then under the circle, we'll have our background. And of course, that should have been a image as well. So UI image background. Let's add this. And let's make this set native size. So it expands the full thing. Also, let's change this to 16 by 9. So there we go. And that covers the whole screen. Now we want to add a mask to this. Now it masks out itself from the background, but we want the opposite. So at the moment, just hit Control F and find this in the scene. Now if we hit R and start scaling it, the transition doesn't look like this. It's actually the opposite of this. It's the negative space that is the black, and then the circle is transparent. So by default, Unity has no option for that, but with a simple script, we can change that. So let's go to our scripts. And I got this solution from a YouTube channel called Code Monkeys. I can't really improve on it, it's pretty perfect. So I want to give a shout out and not pretend that this is all from my own head. This was from Code Monkeys. So I'll link it in the description as well, of course. So let's create a new folder for our UI scripts. Let's call it UI. Let's go in and let's call this C# script inverse mask. Double click to open, and this is actually going to inherit from the image class that already exists. So we'll have to import something. So using Unity Engine .ui. So now we got this image class. Let's remove this stuff. Now we're going to override one of the properties of this class. So public override. The return type is going to be material. Let's just remove this automatic stuff. And the thing we're overriding is the material for rendering. And again, it keeps adding more stuff here, but we're going to do this. So now let's make get, and we create a new material, and this new material Okay, let's just get it first. So the material is actually going to come from the base dot material for rendering. And then what we're going to do is we're going to kind of invert this. So material dot set float, and now we need to add, this is from the shader, so it's one of the keys for the shader. It's called stencil comp. So stencil comp, make sure this is spelled right or it won't work. And then we're going to need this compare function. Like we need to actually import first the using Unity engine.rendering. Rendering, and then we're going to go compare function dot not equal. Now this expects a float, so let's just cast this as a float. Then we will just return this material. We're just missing a bracket here, and that's it. Let's remove this. Again, I got this from the Code Monkeys YouTube channel, their video. It's very good, couldn't improve on it, it's quite perfect, so shout out to them. Now if we go back, so let's just delete this stuff again, because I think there's a little glitch in Unity where it doesn't always render the stuff properly when you change it when it's already set. So again, let's go image, and this is going to be circle, and we're going to add it to our circle. And then we're going to add the mask on to this object. Now this time, instead of creating an image, we're just going to create an empty, call this background. Let's spell it right. And then instead of adding the normal image, we're going to add our inverse mask and add our image and set native. Now, so as we can see, if we put it to full 0, it kind of clips out. So let's go 0.1. Nope, not enough. Let's say 1 opacity. Can we go any lower? 0.5. Nope, it goes to 0. So let's just say 1. So now what we can do, if we hit F, hit R. Now this is how it's going to work. One thing about Canvas too, I want to change our scaling mode. It's going to be scale with screen size. So that means we can change the resolution and it'll still stay the same size. Okay, so let's create some animations real quickly. So we're going to add an animator to this. So add component, animator. And we're going to create our controller, of course. So let's go to our animations folder. Let's create a new one. Folder for the UI, go in here, and let's create another folder for, it's going to be for the transition. Into here, and then let's create our animator controller, circle, back to our circle, give this the controller, and now if we go over to this animations tab, if you don't have this open, you can go Windows, Animations, and then Animation tab, and drag and drop and dock it into here if you want yours to look the same as mine. And we're going to create a new animation. It's in this folder. This one's going to be called Open, or let's do Close first. And we can hit record. So first, if we look at our scene view or game view, this is too small. So what we want to do is make this bigger. So maybe we'll just pull the game view up to here for now so we can see what's going on. And in our circle, let's just find this in the scene again. We need to change the width. So let's see how big we need it until it's outside of the screen. 500. Let's go 1,000. And then same for the height. We're just stretching at the moment. So now we can't see it, but and this is recorded here, this is what these dots are, so we've changed the width and the height. Now if we go to the 60 mark, so that's or sorry, that's 1 second. These are milliseconds. Let's change this now to 0. Now if we hit record, let's go back, hit play. We now see it goes in. And of course, if we go to create a new clip, open, it's going to be the opposite of this. Hit record. This is going to start at 0. And then at the 60 millisecond mark, or 1 second, we'll change this to 1000. Disable the recording, go back, play it. There we go. So now if we click on this and go to our animator tab, we can see that the close is the default. Let's set open to the default, so set as default state. Back to your scene, let's drag our game back down to here. And by default, this is that size. Let's change this to 1000. So it doesn't look like this when we're looking at the screen. Now, if we press play, perfect. We see it's looping. It's easy enough. We'll just go into here, turn looping off for both of them. Great. So that's fine. That the open plays when the scene plays. That's okay. But of course, we need to add some code to this too to trigger the closing when we go to enter a scene. So let's create a UI manager. Create empty UI manager. Let's reset this. Go back to our scripts, our UI folder, create C# script, UI manager, double click to open, and just like our scene handler, we're going to make this a singleton. So public UI manager, so actually public static UI manager instance. Now if we just go to our scene handler, we can just copy and paste this awake method because it's going to be the exact same. Now we're also going to need to get our animator from that circle. So let's say serialized field animator, and let's say transition animator. And now let's create a public method. So public void open transition. And we can just say transition animator dot play, and it's called open. I think we might have used capital O. Let's just double check. Yep, we did. So let's go back, make this capital O, and then also we'll just create one for closing. So let's just copy and paste this. This is going to be closed, and let's change this to close transition. Don't know why I thought adding a C wouldn't make it close. Anyway, video's getting long. Let's remove this stuff, we don't need it. Now let's go back. Our UI manager, we're going to add the UI manager script, of course. And then let's just add this canvas as a child of the UI manager. And let's just change this name to, because we might have multiple canvases, let's call this one transition canvas. And the animator is going to come from our circle. So we actually want this to persist between scenes as well. So if we add this as a child of our scene handler, that means that shouldn't be destroyed on load. So I think we'll actually change this already from scene handler to scene constants. Now let's double check everything. Okay. So let's go back to our scene handler now. This is where we're going to open and close it. So of course, when we first load a scene, we're going to say UI manager dot instance dot close transition, and then when we load a new scene, we want to open the transition again then. So bring this down here, and then open. But we'll see an issue with this. Let's just do it first so I can demonstrate. Press play. Now, let's go over here. As we see, it didn't play, and that's because our game loads really quickly. So let's go out of this. Also, let's just change this to play focused. So let's look at this error first. Don't try and load only works for root game objects or components on root game objects. So actually, you know what? Let's remove this UI manager from here and let's add this to the game constants. I think that would be a better place for it. Apply, and now that will be in the next scene as well. And what we're going to do now is, as we can see there was a bit of time. It went too quick. So we're actually going to kind of make the transition longer than it needs to. We're going to take longer to load the level than we need to. So if we go back to our scene handler, and let's just make a serialized field, float, minimum, scene transition. And we'll probably set that to like 1 second or something. And we're actually going to change this now to a coroutine. So we go I enumerator, and we're going to say load scene. So of course, with an enumerator, we want to return null. Yep, that's fine. It's not causing errors. So this will actually be calling this instead. So start coroutine, load scene. Nope, load scene. Now let's move this code to here. Now we're going to have to add the scene name as a parameter. String scene name. Yeah, of course. So yeah, we need to change this. So let's just rename this. What's a good name for it? It's called coroutine. Let me change it later. Control Z that way. We end up renaming the this method, which we don't want to do that. We just want to change this one. So coroutine. Let's just add this. To here. Okay. So now we're going to have to count down, close transition, count down, load the new scene, play this transition, and then count up, and then we can return our value. So for that, we're going to go back to our tools folder. We're going to create a new handy tool called a timer. It's going to be a very simple script that you can reuse everywhere. Let's open it. So our timer is simply going to have one variable, value. And then we're going to have a method called public void start timer. And here's where we're going to set the value. So this will actually be the max time for the timer. So this will be what we count down from. So value equals max time. That's it for that. And now we're going to create a new method, public void tick, and our tick is going to take in our delta, and if value is greater than 0, then simply value minus equals delta, else value equals 0. And then we want to add a check for this as well. So public bool, let's call this is greater than 0. We're returnable, so to simply return value greater than 0. Very simple script. Let's remove this model behavior because we're not deriving from it, and we can delete all this stuff too. Now if we go back to our UI manager, we can say timer transition timer equals new timer, and then in our, this is the UI manager, so we'll actually let's remove this from here. Go back to our scene handler, add it here instead. We'll say transition timer dot start timer, and it's going to be minimum scene transition. And then we're going to do while transition timer dot is greater than 0, so that means it's still ticking. We're going to say, of course, transition timer dot tick, so taking the time dot delta time. We're not going to use our normal way of capturing the delta because this is only going to be in the script or used once here or twice, so it's no point. And then we're going to yield the return, so yield return null. So we play this, yield return null. Let's actually just add our close first. Yield return null, and then we want to load the scene. We want to open. We want to start the timer again. So let's go here, start the timer, and then same thing again. Copy, and we can remove this. So close, start timer, with timers complete, load the scene, and then we want to open, start the timer, and then we can return this once the timer is complete. Let's go back now. Game constant, do we have any overrides? No. And our scene constants, let's make the minimum transition 1 second. And let's press play, see what happens. So of course we start the scene with the open. Let's go over to our house. There we go, and we get the close. Let's exit the house again and open. Now what's this warning we're getting at the moment? Yeah, we can actually remove this from the UI manager. We shouldn't have added that. That's only for the scene handler. So let's just test this one more time before we end this lesson. Let's go over to the house. Enter. And let's exit the house. Great. And that'll do it for this lesson. Kind of a lot to go through. In the next lesson, we're going to fix this issue of spawning. So as you can see, when we first open the game, we spawn on our normal spot. But then if we go into the house, okay, we spawn here, that's fine. We can set this up within the scene. But once we exit this door, realistically, we want to spawn here again and not back to our default. So you kind of want to spawn this position outside of the house. So that'll be the next lesson. Make sure you subscribe for that one. Should be interesting. And of course, thanks for watching.